Okay, so the next question that we have here is exercise 8.1. And in exercise 8.1, well, I guess I will go through all of the exercises. Let's see. So exercise 8.1, we have you want to expand each of the expressions in exercise 1 to 5. And so, for example, you have number 1, you have 1 minus 2x raised to the power 5. So about this, basically you can use x minus y, or 1 minus x raised to the power n. We had basically 1 minus x raised to the power n, and we wrote that as basically n combination 0 minus n combination 1 times x plus n combination 2 times x squared plus all the way up to negative 1 raised to the power n times n combination n times x raised to the power n. Which means that based on that, basically 1 minus 2x raised to the power 5 is the same thing as 5 combination 0 is equal to 5 combination 0 minus 5 combination 1 times basically x, which is in this case 2x. Then you have plus 5 combination 2x raised to the power 2 minus 5 combination 3, 2x raised to the power 3 plus 5 combination 4, 2x raised to the power 4 minus 5 combination 5, 2x raised to the power 5. So then basically 5 combination 0 and 5 combination 5 are both equal to 1. But then excuse me. So we said that 5 combination 0 and 5 combination 5 are both equal to 1. But 5 combination 1 through 5 combination 4 you have to calculate. So to calculate 5 combination 1, so you have 5 combination 1 is the same thing as 5 factorial over 4 factorial times 1 factorial, which is the same thing as 4 factorial times 5 over 4 factorial times 1 factorial, and that's equal to 5. That is 5 combination 1. Now 5 combination 2 is the same thing as 5 factorial over 3 factorial 2 factorial, which is equal to 3 factorial times 4 times 5 divided by 3 factorial times 2, and then you can cancel these two out. You get a 10 over here. And 5 combination 3 is the same thing as 5 factorial over 2 factorial times 3 factorial, which is the same thing as this one, so it's equal to 10 again. And 5 combination 4 is the same thing as 5 factorial over basically 1 factorial times 4 factorial, which is the same thing as this, and it's equal to 5. So you get 5, 10, 10, 5. So 5, 10, 10, 5, you would get basically 5 combination 0 is equal to 1, and 5 combination 1 is equal to 5. 5 times 2 is equal to 10, that's 10x negative 10x. 5 combination 2 is equal to 10, that's plus 10 times basically 4x squared. 4x squared minus 5 combination 3 is equal to 10. And so you have 10 times 2 cubed is equal to 8 and 8x cubed. And then you have 5 combination 4, which is equal to 5. And then you have 2 raised to the power 4 is equal to 16 times x raised to the power 4. And 5 combination 5 is equal to 1. So you have 32 times x raised to the power 35. So you have negative 32 times x raised to the power 5. So over here you would get basically 1 minus 10x. That is plus 40 times x squared. Minus 80 times x raised to the power 3. 5 times 16 is equal to 50 and 30 is equal to 80 plus 80 times x raised to the power 4 minus 32 times x raised to the power 5. That is the correct answer to question number 1. So question number 1, and that is 13 point, that is the 8.1. We'll find 8.1 here. So that's 1 minus 10x plus 40x squared minus 80x cubed plus 80x raised to the power 4 minus 32x raised to the power 5. So question number 2, you have 2 over x minus x over 2. Question number 2, you have 2, let me find some more space elsewhere. So you have 2 over x. You have 2 over x minus x over 2, whole raised to the power 5. And that is basically the binomial theorem. So the binomial theorem, you can basically write that as n combination 0, so 5 combination 0, a raised to the power or 2 by x raised to the power 5. Then you have 5 combination 1, 2 divided by x raised to the power 4, x divided by 2 raised to the power 1. Then you have 5 combination 2, 2 divided by x raised to the power 3, x divided by 2 raised to the power 2. Then you have 5 combination 3, 2 over x raised to the power 2, x over 2 raised to the power 3. And then you have 5 combination 4, 2 over x raised to the power 1, x over 2 raised to the power 4. And then you have 5 combination 5, 2 over x raised to the power 0 and x over 2 raised to the power 5. Right? Now you know that these are, we already know that 5 combination 1 is 10, 5, 10, 10 and 5. So 5 combination 1 is equal to, I know that 5 combination 1 is equal to basically 5. And 5 combination 2 is equal to 10, and 5 combination 3 is equal to 10, and 5 combination 4 is equal to 5. And therefore I can write this as 5 combination 0 is equal to, and you know that 5 combination 0 is equal to 1, and 5 combination 5 is equal to 1. And therefore I can write this whole thing as basically 5 combination 0 is 1. So 2 raised to the power 5 is equal to 32 divided by x raised to the power 5. 5 combination 1 is equal to 5 plus 5 times, and you have a negative sign here. And we said that basically when you have a minus b or x minus y, so we showed that basically x minus y raised to the power n was equal to basically n combination 0, x raised to the power n minus n combination 1, x raised to the power n minus 1, y raised to the power 1, plus n combination 2, x raised to the power n minus 2, y raised to the power 2, minus n combination 3, x raised to the power n minus 3, y raised to the power 3, plus all the way up to negative 1 raised to the power n, negative 1 raised to the power n, x raised to the basically n combination n, n combination n, x, y raised to the power n, right? So you get positive, negative periodically, which means that over here you get positive, this would be a negative sign, and this would be positive, this would be a negative sign, this would be a negative sign. So you would write positive, negative, positive, negative, positive, negative, which means that over here you have 32 over x raised to the power 5, okay, so you have 32 times 32 divided by x raised to the power 5, and then you have basically 5 combination 1, which is equal to 5 times minus 5 times, then 2 divided by x raised to the power 4, 2 raised to the power 4 is equal to 16 by x raised to the power 4, and that is x divided by 2, right? Then plus 5 combination 2, 5 combination 2 is equal to 10, is equal to 10, that's 2 cube is equal to 8 by x raised to the power 3. And then you have x squared over 2 squared is equal to 4, right? And then we have 5 combination 3, which is equal to 10, so that's negative 10 times 2 squared is equal to 4 over x raised to the power 2 over x raised to the power 2, and you have x cubed over 8, and you have x cubed over 8, and then you have plus 5 combination 4 is equal to 5, so plus 5, and then you have 2 over x, x raised to the power 4, 2 raised to the power 4 is equal to 16, right? 16. And then you have minus 5 combination 5 is equal to 1, this is 1, and then that's x raised to the power 5 over x raised to the power 5 over 32. Now you can simplify this a little bit, meaning that you can write basically 32 over x raised to the power 5, 32 over x raised to the power 5, and then you can write this as 8 and as x cubed, and that is the same thing as basically 5 times negative 5 times x is equal to 40 over x raised to the power 3. 8 divided by 4 is equal to 2 times, and that gives you an x, so that's 20 times x plus 20 divided by x, minus, that is a 2 over here, 10 divided by 2 is equal to 5, and then over here you'll get an x, that's negative 5x, negative 5x. Then you have 2 divided by 16 is equal to 1/8, that's plus 5/8, and you will get x cubed over here, plus 5/8 5x cubed over 8. And then you have negative x raised to the power 5 over 32. So the correct answer here is, for question number 2, is 32 over x raised to the power 5 minus 40 over x cubed plus 20 over x minus 5x plus 5/8 x cubed minus x raised to the power 5 divided by 32, which is the correct answer. Okay, so part 3 of this question is 2x minus 3 raised to the power 6 is 2x minus 3 raised to the power 6. So you can take that as you see there is something over here. If you have 2x minus 3 raised to the power 6. So basically we showed that basically 1 minus x, well, which is of course, it has nothing to do with here, so let's forget about that. So 2x minus 3 raised to the power 6 is equal to, you can call it, for example, x minus y raised to the power n, and then you can write this as basically n combination 0, which is 6 combination 0, 2x raised to the power 6, and then you get a negative sign here, and 6 combination 1, 2x raised to the power 6 minus 1 is equal to 5, and then 3 raised to the power 1 plus negative positive 6 combination 2, 2x raised to the power 6 minus 2 is equal to 4, and then 3 raised to the power 2, and then you have 6 combination 3, 2x raised to the power 6 minus 3 is equal to 3, and 3 raised to the power 3 minus positive, actually negative positive, again over here you should have a negative and a positive here, positive, negative, positive, negative, and positive. Then you have 6 combination 4, 2x raised to the power 2, and 3 raised to the power 4, minus 6 combination 5, 2x raised to the power 1, and 3 raised to the power 5, plus 6 combination 6, 2x raised to the power 0, and 3 raised to the power 6. Alright, so that is that. Now you can write this as you can write this as 6 combination 0, so 6 combination 0 is equal to 1, and 6 combination 6 is also equal to 1. But then for the rest of the things, so 6 combination 1 through 6 combination 5 you need to calculate. So 6 combination 1 is equal to basically 6 factorial over 5 factorial 1 factorial. You can write that as 5 factorial times 6 divided by 5 factorial times 1 factorial, and that you can cancel out. You'll end up with 6. 6 combination 2 is the same thing as basically 6 factorial, 4 factorial, and 2 factorial. So you can write that as 4 factorial times 5 times 6 over 4 factorial times 2, and then you can simplify this, and 3 times 5 is equal to 15. 6 combination 3 is equal to basically 6 factorial, 3 factorial, 3 factorial, which is equal to 3 factorial times 4 times 5 times 6 divided by 3 factorial times 3 factorial is equal to 6 These two you can cancel out, these two you can cancel out, you get the 20. 6 combination 4. 6 combination 4 is the same thing as 6 factorial, 2 factorial, 4 factorial, 4 factorial, and this is the same thing as 6 combination 2, so that's equal to 15. And 6 combination 5, and I'm saying it's the same thing as 6 combination 2 because if you compare these two fractions, you see that they are the same things. 6 combination 5 is 6 factorial, 1 factorial, 5 factorial is the same thing as 6 combination 1, which is equal to 6. So 6, 15, 20, 15, 6. And now you can write this as basically 6 combination 0 is equal to 1 times 2 raised to the power 6 is equal to 16. 16 times 4 is equal to 16 times 4 is equal to 40, and 24 is 64. So 2 raised to the power 6 is equal to 64. 2 raised to the power 6 is equal to 64, and x raised to the power 6 is x raised to the power 6. Now 6 combination 1. 6 combination 1 is the same thing as 6, right? That is the same thing as 6. And 2 raised to the power 5 is equal to 32. 3 raised to the power 1 is equal to 3. X raised to the power 5 is equal to x raised to the power 5. 6 combination 2 is the same thing as 15. Is the same thing as 15. 2 raised to the power 4 is equal to 16. 3 raised to the power 2 is equal to 9. And x raised to the power 4 is x raised to the power 4. 6 combination 3 is the same thing as 20. So you have negative 20 times 2 cube is equal to 8. And 3 cube is equal to 27. And then you have over here x cubed. 6 combination 4 is equal to 15. 6 combination 4 is equal to 15. 2 squared is equal to 4. And 3 raised to the power 4 is equal to 81. 3 raised to the power 4 is equal to 81. And that is times x squared. 6 combination 5 is equal to 6. 6 combination 5 is equal to 6 times 2 times 3 raised to the power 5 is equal to basically 3 raised to the power 4 is equal to 81. 81 times 3 is equal to 243. 243, and then you have times x. So that's basically all that you have so far. And then you have basically 64 x raised to the power 6. You have 64 x raised to the power 6, and you have basically 18 times 32, 32 times 18. So that's the same thing as, 10 times 32 is equal to 320. 8 times 32 is 8 times 3 is equal to 240. 16. That's 256. 320 plus 256 is equal to 7 and 5, 576. So that is negative 576 times x raised to the power 5. Next, so you have 9 times 15 times 16. So 15 times 16 times 9, let's say that you have 10 times 15 is equal to 150. 150 minus 15 is equal to 140, 135. So you have 135 times 16, right? And 10 times 135 is 1350. 6 times 135 is equal to 6 times 100 is equal to 600. 6 times 3 is equal to 1880. And 6 times 5 is equal to 30. So there you will get 0. 11 plus 5 is equal to 16, 1. So 11 plus 5 is equal to 16, 1. And 9 plus 2 is equal to 11, 1. And that's 2160. So that's negative. That is negative 12123. So over here plus 2160 x raised to the power 4. Then you have 20 times 8 times 27, which is the same thing as 160 times 27. 160 times 27. That's the same thing as 27 times 16. 27 times 10 is equal to 270. 6 times 20 is equal to 120. 6 times 7 is equal to 42. Add them together, you'll get 9. 9 plus 4 is equal to 13, 1, and that's a 432. And you have a 0 over here, so you'll get 4320. So the 1, 2, 3, 1, 2, 3, the fourth term over here, it's negative 4320 x raised to the power 3. Now 4 times 15 is equal to 60 times 81. So 6 times 8 is equal to 48, 480 and 6. And so you have, and 400, so that is 486. And you have a 0 there, 4860. 4860. Plus 4860 x raised to the power 2. And then you have basically 12 times 243. 243 times 12 is equal to 684. And 243, you will get 6, 1, 1, 5, 4, 8, and 9. 2916 minus 2196, 2916, I'm sorry. 2916 times x. So the answer to question number 3 is basically 64 x raised to the power 6 minus 576 x raised to the power 5 plus 2160 x raised to the power 4 minus 4320 x raised to the power 3 plus 4860 x raised to the power 2 minus 2916x. There is something left here that we have forgotten over here. That's 6 combination. 6 is equal to 1, and this is 1. 3 raised to the power 6 is basically 9 times, no, 3 raised to the power 4 is equal to 81. 81 times 9 is equal to basically 729. So plus 729. which means that 3 raised to the power 6 is equal to 729. 729. Okay. So that is that. Now, question number 4. Question number 4, we have x over 3 plus 1 over x, x over 3 plus 1 over x raised to the power 5. Okay, so this is question number 4, and you can think of this as basically the binomial theorem itself, meaning that you can write this as basically basically 5 combination 0. You can write this as 5 combination 0, basically x over 3 raised to the power 5 plus 5 combination 1, x over 3 raised to the power, basically 5 minus 1 is equal to 4, 1 over x raised to the power 1, plus 5 combination 2, x over 3 raised to the power 5 minus 2 is equal to 3, 1 over x raised to the power 2, and then you can write 5 combination 3, x over 3 raised to the power 2, and 1 over x raised to the power 3, plus 5 combination 4, x over 3 raised to the power 1, 1 over x raised to the power 4, plus 5 combination 5, x over 3 raised to the power 0, and 1 over x raised to the power 5. Okay? And then you know that 5 combination 0 and 5 combination 5 are essentially equal to 1, and this is 5, 10, 10, 5, I suppose. 5, 10, 10, 5. So you can write this as 1 times x raised to the power 5. 3 raised to the power 5 is the same thing as 3 raised to the power 4 is equal to 81. 81 times 3 is equal to 240, 243. And then you have basically 5 combination 1, which is equal to 5. And then x raised to the power 4. 3 raised to the power 4 is equal to 81. And you have 1 over x over here. Then you have 10 times 5 combination 2 is equal to 10. X raised to the power 3 over 27 times basically times 1 over x squared, 1 over x squared, plus 5 combination 3, which is equal to 10, x squared over 9, 1 over x cubed, 1 over x cubed. And then you have basically, so you have 1, 2, 3, 4, 1, 2, 3, 4. 5 combination 4 is equal to 5. 5 combination 4 is equal to 5, x over 3, 1 over x raised to the power 4. And they have basically 1 and 1 over here, 1 over x raised to the power 5. Next, you can write this as basically x raised to the power 5 over 243. And then x and x cubed you will get over here. So you have 5 over 81 times x cubed. Next you will get an x over here, so 10 over 27 times x. And then you have basically, you get an x over here, 10 over 9 times x. And then over here you have basically an x cube over here. And so you have 5/3 times x times 1 over x cubed. So you get 5/3 times x cubed. And then you have 1 over x raised to the power 5. So that was question number 4. So question number 4 is x raised to the power 5 over 243 plus 5 over 81 times x cubed plus 10 over 27 times x plus 10 over 9x plus 5 over 3 plus 5 over 3x cubed plus 1 over x raised to the power 5. This was question number 4. This was on question number 4. Question number 5. Question number 5, I think we need a little bit more space here. Question number 5, we have x plus 1 over x, all raised to the power 6. All raised to the power 6. So that is the binomial theorem itself. So you can write it as 6 combination 0, x raised to the power 6, and 6 combination 1, x raised to the power 5, 1 over x raised to the power 1, 6 combination 2, x raised to the power 4, 1 over x raised to the power 2, plus 6 combination 3, x raised to the power 3, 1 over x raised to the power 3, plus 6 combination 4, x raised to the power 2, 1 over x raised to the power 4, plus 6 combination 5, x raised to the power 1, 1 over x raised to the power 5, plus 6 combination 6, x raised to the power 0, 1 over x raised to the power 6. So, so 6 combination 0 and 6 combination 6 are equal to 1. So then you can write this as, but the rest of these you need to calculate. The rest of these you need to calculate, meaning that 6 combination 1, for example, 6 combination 1 is equal to 6 factorial, 5 factorial, 1 factorial, which is the same thing as basically 5 factorial times 6 over 5 factorial times 1 factorial, and that is equal to 6. And of course, always n combination 1 is equal to n. So 6 combination 1 therefore is equal to 6, right? Now 6 combination 2 is equal to basically 6 combination 2 is equal to 6 factorial, 4 factorial times 2 factorial, which is equal to 4 factorial times 4 times 5 times 6 divided by 4 factorial times 2, and you can cancel these two out, you'll get a 15 over here. And then you have 6 combination 3, which is equal to 6 factorial, 3 factorial, 3 factorial, which is equal to 3 factorial times 4 times 5 times 6 divided by 3 factorial times 6. Then you can cancel these two out. That is a 20. 6 combination 4 is equal to basically 6 factorial, 2 factorial times 4 factorial, which is equal to basically 4 factorial times 5 times 6 divided by 2 times 4 factorial, and then you can cancel these two out. We'll get a 15 over here. And 6 combination 5 is the same thing as 6 factorial, 1 factorial, and 5 factorial, which is the same thing as this one, which is equal to 6. Okay. So then you can write this as 6 combination 0 is equal to 1 and x raised to the power 6. 6 combination 1 is equal to 6, of course, plus 6 times x raised to the power 5 over x is x raised to the power 4. X raised to the power 4. 6 combination 2. 6 combination 2 is equal to 15. It's equal to 15. And this is x squared. X raised to the power 4 divided by x raised to the power 2 is equal to x raised to the power 2. 6 combination 3 is equal to 20. And x cube over x cube is equal to 1, right? 6 combination 4 is equal to 15. 15 times basically x squared over x raised to the power 4 is 1 over x squared. 1 over x squared. 6 combination 5 is equal to 6. And so you have x over x raised to the power 5, which is equal to 1 over x raised to the power 4. And then you have 6 combination 6, that's 1, that's basically plus 1 over x raised to the power 6. So that's the same thing as x raised to the power 6 plus 6 times x raised to the power 4 plus 15 times x raised to the power 2. And then you have basically plus 15 over x raised to the power 2, and keeping this for the last term, plus 6 over x raised to the power 4 plus 1 over x raised to the power 6 plus 20. That's question number 5. So that's x raised to the power 6 plus 6 times x raised to the power 4 plus 15 times x squared plus 20 plus 15 over x squared plus 6 over x raised to the power 4 plus 1 over x raised to the power 6. That's question number 5. Question number 6. Question number 6, we have, using binomial theorem, evaluate each of the following calculations. So for example, if you have 96, that's question number 6. You have 96 raised to the power 3. So 96 raised to the power 3, you can write it as 100 minus 4 raised to the power 3. That is x minus y raised to the power 3. Okay, so you can write this now as x minus y basically raised to the power n, and you already know that that's equal to basically n combination 0, so 3 combination 0. For example, 100 raised to the power 3. So here you have a positive, so you get a negative here. 3 combination 1. 100 raised to the power 2. And then 4 raised to the power 1. Plus and negative positive 3 combination 2 times 100 raised to the power 1, 4 raised to the power 2. and then you have 3 combination 3, 3 combination 3, 100 raised to the power 0, and 4 raised to the power 3. 4 raised to the power 3. So 3 combination 0 is equal to 1. 3 combination 3 is equal to 1. 3 combination 1 is equal to 3. So the only thing that you need to calculate is 3 combination 2. And that should be also 3, of course, because that's 3 factorial divided by 1 factorial, 2 factorial, that's equal to 2 factorial times 3 divided by 2 factorial, that's equal to 3, right? So this is 3, this is 3, this is 1, and this is 1. And so you can write this as basically 1 times 100 raised to the power 3, which is equal to basically 6 zeros you will get here. And 3 combination, so negative 3 times 100 raised to the power 2, you'll get basically 4 zeros there. So 1 0 0 0 0 times 4. 3 combination 2 is equal to 3 times 100 times 16. 100 times 16. And that's 1 times 4 raised to the power 3 is equal to 16 times 3 is equal to basically 30. 30 and 18, that's 48. That's 48. So you get positive, negative, positive. That should be actually a negative sign. This is important. That should be a negative sign. So that's negative 48. And therefore, you will get basically that is 1 million. And that is basically 12 times 10,000. That's 120,000. That's 1 million. That's 1 million. That's 120,000. And that's 3 times 16 is equal to 30, 18, 48, 4,800 plus 4,800 minus 48, which is the same thing as basically, which is the same thing as 1 million. So you get 1 million here and then 4, so 004800. That's the sum of these two numbers. The sum of these two numbers becomes 120048. Subtract this number from this number, you will get 6 digits. So you have 120048. Subtract, you will get basically 7, 9, 10. So you have a 2, you have a 9 minus 4 is equal to 5, 7, 0. And then you have 4 minus 0 is equal to 4. And then you have a 0 over here, 9 and 10. So 10 minus 2 is equal to 8 and 8. So you get 884052. 4052. That is basically 96 cube. 96 cube over here is equal to 96 cube is equal to 884736. 884736. There is some problem here. Let me do this calculation on a calculator. So that's 12 and 4 zeros. That's 3 times 16 is equal to 4800 minus 48. So let me do the calculation. 100000 minus 120000 plus 4800 minus 48 equal to 884752. Oh, there's something wrong here. So you have basically 3 combination 0, 3 combination 1, 3 combination 2, 3 combinations 3, positive, negative, positive, negative. There's something wrong here. So 3 combination 0 is equal to 1, 10, 100 cube is equal to basically 6 zeros, so that's 1 million. Now this is 3 and this is 10,000, 2 zeros. 4 zeros times 4 is equal to 12 times 12 and 4 zeros. You get 120,000. 120,000. And that's 4 squared is equal to 16. 16 times 3 is equal to 16 times 3 is equal to 48. 4800 plus 4800 minus, over here you have 4 cube is equal to 64. That's actually equal to 64. That is equal to 64. Because 4 squared is equal to 16. 16 times 4 is equal to 16 times 4 is equal to basically 40 and 24, which is equal to 64, right? And then if you add these numbers together, you will get 64. So you have basically 1 and 0, 0, 4, 8, 0, 0. This is the sum of these two numbers. The sum of these two numbers becomes 1, 2, 0, 0, 6, 4. And then you have 2, 4, and 6. 2, 4, and 6. So you have basically 1, 2, 0, 0, 6, 4. Subtract, you will get 7, 9, 10. And you have a 6 over here, a 3 over here, a 7 over here, a 4 over here, and a 0, 9, and 10. And you have an 8 over here and 8 over here. So you get 8, 8, 4, 7, 3, 6. And that is the same thing as 96 cube is equal to 884 736, which is the correct answer. So that's 884 736. That's the correct answer there. Okay, so that was question number 6. Question number 7 is 102 raised to the power 5. 102 raised to the power 5. Question number 7 is 102 raised to the power 5. You can write this as 100 plus 2 all raised to the power 5, the binomial theorem. So you can write it as 5 combination 0, 100 raised to the power 5, plus 5 combination 1, and all you get positive terms. 5 combination 100 raised to the power 4 times 2 raised to the power 1 plus 5 combination 2 times 100 raised to the power 3 times 2 raised to the power 2 plus 5 combination 3, 100 raised to the power 2, and basically 2 raised to the power 3, 2 raised to the power 3 plus 5 combination 4, 100 raised to the power 1, 2 raised to the power 4, and then you have 5 combination 5, 100 raised to the power 0, 2 raised to the power 5. So 5 combination 0 is equal to 1, So that is 100 raised to the power 5 is equal to basically is equal to 1 with 10 zeros. So you have basically 1 with 10 zeros. So you have, that is 1 with 10 zeros. 9 plus 1 is equal to 10. 5 times 2 is equal to 10. 3, 6, 9, and 10. Okay. 5 combination 1 is equal to 5. And 100 raised to the power 4, that's 1 with 8 zeros. That means that 1 0 0 0 0 0 and 6 plus 2 is equal to 8. So 0 0 0, that's 100 million times 2. 5 combination 2 is the same thing as 5 factorial 3 factorial times 2 factorial, which is equal to 3 factorial times 4 times 5. 3 factorial times 2, cancel these 2 out. 2 times 5 is equal to 10. So that is 10. 100 raised to the power 3 is basically 6 zeros, so that's a million. 6 zeros there. 2 raised to the power 2 is equal to 4. 5 combination 3 is the same thing as 5 factorial, 2 factorial, 3 factorial. It's the same thing as this, so this becomes a 10. So that is 10 times 100 raised to the power 2 is equal to 10,000. That means that 10, 0, 0, 0. And 2 raised to the power 3 is equal to 8. And then you have 5 combination 4. 5 combination 4 is the same thing as basically 5 factorial over 1 factorial 4 factorial. Five factorial, 1 factorial, 4 factorial, which is the same thing as basically 4 factorial times 5 over 4 factorial, that's equal to 5. So 5 combination 4 is equal to 5. So that's equal to 5 times 100 times 2 raised to the power 4 is equal to 16. Next you have 5 combination 5, which is equal to 1. This is equal to 1. 2 raised to the power 5 is equal to 32. Right? Next, what you have is basically just have to add these numbers together. That's 10 billion. That's 10. That is the same thing as, so you can write this as 10 billion. And then 5 times 2 is equal to 10. 10 times this would be 1 0 added to this, so you'll get again another 10 billion. So you get basically 1 0 0 0 0 0 0 0 0. That's 1 billion, excuse me, 1 billion. And you have basically 4 times, actually that is 10 million, right? That's 1 million times 10 is equal to 10 million. That's 40 million plus 40 million. 40 million, that is 10,000 times 10 is equal to 100,000, 800,000. 800,000. That is 16 times 5 is equal to 50 and 30. That's 80 times 100 is equal to 8,000. 8,000. And that's 32. That is 32. Now adding these numbers together, you will get 10 billion you'll get 10 billion, and you have 1 billion, and you have 40 million, you have 40 million, and you have 800,000, and you have 8,000, and you have 32. Adding all of these together, you will get basically a 2, a 3, a 0, an 8, a 0, an 8, a 0, a 4, a 0, a 1, and a 1. And that's the same thing as basically 11 billion, 40 million, 808,032. And if you actually do this calculation on a calculator, which is 102 raised to the power 5, 102 raised to the power 5, you will get 11,040,808,032. 11,040,808,032, which is the correct answer. Okay. This was question number 7. We will continue these questions in the next video. Thank you.